everyone. I am here to do a brief review is what I want to call it, but kind of just walk through some information about the test. And I want to preface this with, I've put some work into this PowerPoint, this presentation, but I don't actually have really any practice problems. I'm kind of just going to come up with some I would love to say talk about it, but as I talk through some of the problems, and I do think that this is something you all are more than capable of doing and kind of using this as a model to help yourself study and think about the resources that you have. So I know it can be overwhelming and you might think, oh my God, I don't even know where to look for that. So I do have that incorporated into here as of like, which weeks should you look for to find this stuff so that you know where to kind of go back and reference, because I know that can get overwhelming. So hopefully this brings some clarity and you feel you're ready to maybe jump into your own studying and think of ways to do that after this and use this as a guide and a model, and hopefully this is helpful. So with that being said, let's go back through the topics for the test. So I'm going to start from the very beginning, and maybe you can think back to all the things that we have done up to this point in Unit 1. Oh, that rhymed. Did anyone catch that? So the very first thing we started with was number systems. What did we do after that? We talked about functions. Right? So we did the number systems, we had a number system reading, and then we introduced functions. And with that came stuff like function notation, right? So 2 and 3, they definitely go together. We talked about domain and range graphically. We really did all of these 2, 3, and 4 together. They go together. I wanted to list them separately because I don't want you to forget something within there. I kind of was like, hey, how do you know if something's a function? What is function notation? How do you find domain and range graphically? What are the little things that we should remember about that you guys have really been continuing to work with the skills that you built here over the last few weeks. So this isn't stuff that we haven't looked at. There's a lot of overlap and connections that hopefully you're seeing as I'm putting up this list. From there, we talked about finding domain algebraically, and we literally haven't stopped. Right? Like that has been in everything we have talked about. That has not been a skill or an objective that has disappeared as we've moved forward because it is so important to us. And we knew that it required work and practice. So that's where we did domain busters. And then we went into function operations and we focused first on the basic operations is what we referred to them as, which are addition, subtraction, multiplication, and division, still with domain. And when I'm saying basic operations, I'm not saying that they're easy. I'm saying that addition, subtraction, multiplication, division are what are referred to as the basic operations. And then we incorporated composition into that, right? Still with domain. And we continued to work with those function operations. We continued to work with domain busters. So notice like so much overlap here. From there, we introduced the 5 fun facts of inverses, which incorporated a lot of the things that we've talked about before. Right? This is all about functions. And then finally, we ended with this topic of equations and amputations, which links into that one of the 5 fun facts as well. So this is like, if I'm going 1 through 9, and I feel like I probably could have grouped some of these together, really the topics that we've learned so far and that we've really developed a lot of skills with. And I do want you to kind of take a step back and be like, oh my God, I don't necessarily need to study finding domain algebraically. I can do that within function operations and within composition, right? If I know how to do composition, I know how to verify that 2 things are inverses using composition, right? So a lot of these things are coming into play here where like, you don't need to look at them as 9 separate topics. Find the overlap if you haven't already and try to make those connections and talk through them and see how can I have a problem that incorporates a few of these, right? Like maybe it doesn't individually check that I know what a function is, but through the 5 fun facts of inverses, I could get asked a question about that or including this idea of equations and amputations. So I really would like for everyone to really, if you haven't already, think through the connections between these things. So I'm going to go into each one of these over the next few slides. So the first one I'm going to start with is number systems. And I wanted to put this out here, and you guys have access to this PowerPoint to help. But if you go into the archived pages and you go back to the very first week, which is week of August 31st, you will find information about the number systems. So I would encourage you to go back to that. I would encourage you to go back and review the read it. I wouldn't spend so much time doing that. But I would go back and review the reading and think about the things that maybe you didn't know before. Many of you shared information that wasn't surprising to you. We've worked with a decent amount of them. Are there certain symbols, right? Maybe the all real numbers, this one you knew. I don't need to spend time on that, but maybe I struggled with natural numbers. Maybe I didn't remember what this was the symbol for. It's rational, by the way, right? And then maybe I can make the connection that this is irrational. Maybe I didn't know that this was natural numbers, and I wasn't sure if natural numbers included 0 or not. There was a Quizlet on this. That isn't a bad thing to review. I probably wouldn't spend all of my time doing this because if you remember, what we did with the number systems was it wasn't as much about do you know what each one is, but if you're asked to solve an equation over the set of natural numbers, do you know what that means? Right? So that's the idea of this. It's not so much as identify, but can you do that? And then remember for IB, we are working under the real number system unless it says otherwise. Oops, sorry. Forgot I had another bullet that came up. I wrote over it. It's okay. And then we got into what is a function. Isn't this font really pretty? Just wanted to acknowledge that. So what is a function? This was the second week. So week of September 7th is the page that I would go and look at if you're looking for information or more practice, right? Maybe you had some supplemental resources you didn't go into for that. So what is a function? The vertical line test, right? If it passes the vertical line test, the VLT, it's a function, right? If every domain value results in a single range value. If this is true, it is a function, right? So if I am looking at something that looks like, woo, that's a function, right? If I'm looking at something and it's like this, not a function. Look what happens when I draw vertical lines, right? And we also looked at it as sets of numbers. So if you had like 2, 4, 5, 9, 8, 9, -2, 4, that's a function, right? This is a function. None of my domain values repeat. Only my range values do, but that's fine. My range values do when I'm looking at a parabola, when I'm looking at a quadratic, and that's a function. Every input has one output. With this, we started to incorporate function notation. So this was those 2 weeks, right? So it was the week of September 7th and then the week of September 14th as well. So it kind of went into both there, and I feel like we really haven't stopped working with it. So this is what function notation looks like, right? If something's not a function, it doesn't mean we don't care about it. We still like it. It is useful to us. There are things that are not functions. Remember you learned about circles. Not a function. We still care. It's still important to us. And you'll see that importance again through this course later on. So this is not a function. If it's not a function, just use y. Right? F of x is the equivalent to y. It's just the notation we use for a function. What does something like f of 7 mean? So this means that your input is 7. This means that your output is 4. Right? So if you had something and I said, well, f of x equals x squared minus 9 over 2. And I said, find f of 7. Well, that means that I'm going to show my work. 7 squared minus 9 over 2. 49 minus 9 over 2. I mean, I didn't even know that this was going to work so nicely. Which is 20, right? Show your work. If it says that word find, I should be showing some process, not just my final answer. Right? And then for something like this, well, if this was f of x and I was like, hey, what's f of 4? I'm sorry. When is f of x equal to 4? Well, I'm going to go ahead and I'm going to say 4 equals x squared minus 9 over 2 times 2. 8 equals x squared minus 9. Add 9. What is that? 17 equals x squared. Ooh, I like that I did this one. My goodness, that's plus or minus the square root of 17 is x. Be careful, I actually get two solutions there. It's a function. It has two output values, but my input value doesn't repeat. Right? This is similar to if I had some sort of graph. I don't know. I'm just going to like draw something. I don't know what I'm, oh no, that wouldn't be a function. Oh boy, sorry. That wouldn't be a function, right? If I filled that in, it wouldn't be a function. But let's pretend that this one was an open circle. So let's say I asked you for f of -2. Let's say this is f of x. F of -2, I'm gonna go over to -2. Oh, that's just gonna be 0, right? There's an open circle there. If I asked you, where is f of x equal to 5, I would go up to 1, 2, 3, 4, 5, go over, and then down. I don't know what that is, but let's say it was 6. Right? That is the idea of like function notation here. Do I have anything else pop up? Oh, thank God. With this idea, we talked about domain and range graphically, which I kind of just started, right? This was the same 2 weeks, right? It was all incorporated there because these really weren't separate concepts. We included them together, but I'm just talking about them now separately. So the domain is all the x values, goes left and right. The range is all the y values, bottom to top, right? Smallest to greatest is where we're going here. And then remember what we had interval notation and what type of brackets to use. So if you're dealing with something that is like this, and this is graphically, right? So let's say I had something that looked like this. Let's say this is 1. Your domain is going to be from 1 to infinity, or you can say x is greater than or equal to 1 because it includes, remember, it's this hard bracket. Your range would be 0 to infinity. And now remember, it never reaches infinity, or y is greater than or equal to 0. If I gave you another one and said, let's say it was like that. This is a tricky one. Let's see, the domain, it's going to go from negative infinity to, what is this, 1, 2, 3, -4, and it's going to include it. Then it jumps. Look, nothing in here counts. It goes to -2, which is not included, to infinity. The range, I could have also said x is less than or equal to -4, or x is greater than -2 if I wanted. The range here, well, it doesn't matter that there's an open circle here, right? It goes below there. It's just y is greater than or equal to 0, or you could say 0 to infinity. Right? Remember, you're going from least to greatest. If you have something that is like a parabola that opens down, your range is going to be from -infinity, start from the bottom, to -2, including, right? So be careful there. So, and there was Delta math practice on this that was assigned, I feel like, several times to you all. So if you're looking for more problems to practice this skill, go for it. Like, use that. Oh, what do open circles and closed circles mean? Open circle is including, closed circle. I'm sorry, closed circle is including, open circle is not including. And then we did domain and range algebraically, and I feel like this is really where we get into like what we've been consistently and regularly working with. So this is the week of September 14th was when we started it. So this is domain busters, right? This is your first introduction. There's a video lesson on this. So you can't divide by 0. You cannot take the square root, or I said even root. Square root's really what we've been working with, but like you can't take a 4th root or a 6th root or an 8th root. You don't have to worry about that. Focus yourself on square root, but it's the same idea. You can take a 3rd root. You can take a 5th root. You just can't take a square root of a negative or an even root. And then I said sketch a picture if it helps. Oops, sorry. So let's see. I'll do 2 examples of this because we're going to be doing it more. Let's see. I'll go with example 1 here. So let's say we had something like, I'll call it g this time, of 2x over the square root of x squared minus 4x minus 5. I'll go with that. So in something like this, we can't take the square root of a negative, and you can't divide by 0. So this one's got like the double whammy here. So what I would encourage you to do is take what's under this radical and figure out where it is 0, and then go from there. Where is this 0? It can't be 0, but let's figure out where it is 0, and then kind of move on from there. So if you're dealing with a quadratic, we're going to have to factor it. X minus 5, x plus 1. So you've got 5 and negative 1. Those are the 2 spots where it's 0. It can't equal to those. You can't divide by 0. Let's stick them on the number line. It can't equal to this. Let's put open circles. This is 0. So I want to know, well, where is this, what's under the radical? Where is that positive and where is that negative? Well, that's going to be a parabola that opens up. Those parts are fine. This part is not fine. So for the domain of something like this, you're going to go from negative infinity to negative 1, not including it. And then again, from 5 to infinity. Or maybe you're going to write it as x is less than negative 1, or x is greater than 5. Let's do another example. Let's call it h of x this time. Let's say you had square root of x squared minus 16. You know what? Divided by x. I'll make these challenging. Maybe you see how I'm just coming up with them? You can do this too. This doesn't require a math degree or to be a math teacher to come up with these. You just write something. Think about the if you're able to create these problems, awesome. If you're not comfortable creating, go use some of the resources and just pull problems. You know what? Even better, work with a friend or a sibling and make them quizzes. Make them practice quizzes. Oh, I love that idea. And then send them to me so I can send them to everyone. I love that idea. Wow. Okay. So here, can't take the square root of a negative, can't divide by 0. I've got so much going on here. You know what I already know I'm kicking out? The value 0. It can't be 0. So then let's analyze what's under that radical. Let's figure out where what's under this is 0. So if I go to solve this, x squared equals 16, and I get x is plus or minus 4, right? So it can be positive and negative 4. It just can't be negative, right? So negative 4 and 4 are both fine. Again, that's going to be what's under there is going to be a parabola that opens up. This is the part that's bad. So from that top part, I get that x is less than or equal to negative 4 and x is greater than or equal to 4. So I want you to think about this all together. Let me grab a new color here. No, I keep going back. I want like a blue maybe. Maybe if you could say it. One of you guys should invent that. So x has to be less than negative 4, greater than or equal to 4, and not equal to 0. Well, 0 is like smack dab in the middle of here. So it can't equal 0 anyways. I actually do not even need to say this. Right? Me saying that it's from negative infinity to negative 4, including it, union 4 to infinity, this within itself gets rid of that 0. That 0 is not even a part of that. We don't even need to think about that. Because it's not. It's in this part I'm not even writing. Right? So it's important to us. It can't be 0. But with these restrictions, with this domain, 0 is not even included in this domain anyways. This is all I would need to say. So this is definitely a challenging one. But if you're understanding this process and you can work through this and use something like, maybe use GeoGebra, because we found some errors in Desmos, to check your work, amazing. Okay. Then we got into function operations, and this really puts us at the end of this unit almost. So we did this September 14th and September 21st for the 2 weeks. We did add, subtract, multiply, and divide. One of the big things was finding a common denominator when you're adding and subtracting, which there's been a lot of growth with for all of you. So dividing by a fraction, multiplying by the reciprocal, and then making sure to find the domain right when you set it up was a huge emphasis. So I'm not going to do an example right on this page because I want to talk about composition and then do an example for all of that. So hopefully that is okay with you guys. And I'll do one maybe with a fraction that you would have to simplify. So I think that's good. Then we did function composition the week of September 21st. Substitute one into the other, and then I just said read carefully, right? Is it asking you for f of g of x, g of f of x? Right, be careful that you're not confusing composition with multiplication, right? Don't rush yourself that much. Read carefully. Find domain right when you substitute. Again, simplification is important to do, but it can mask restrictions that are really still there. And my emphasis again is use GeoGebra. I know I keep saying use Desmos, but we found some errors within Desmos. Oops, sorry. So I'm going to do an example here, and I'm actually going to do all the operations. Let's see. I'm going to write it up here. F of x, I want f of x to be x plus 2 over x minus 1, and I want g of x to be 3x. Yeah, I want it to be 3x. So let's do adding. If I add f plus g of x, right, that's a notation that you might see. So that just means that you're adding the two functions together. I'm not multiplying by x, be careful. This is saying f of x plus g of x. That's what this notation indicates to us. I would have x plus 2 over x minus 1 plus 3x. You know what? I think this is where I'll find my domain. Before I even simplify, the domain x cannot equal 1. Can't divide by 0. Alrighty, so let's find that common denominator. I'm going to multiply this one by x minus 1 over x minus 1. But I'm not actually changing it. So then you've got x plus 2 over x plus minus 1 plus 3x squared minus 3x over x minus 1. And then you're able to add them. So I'll do my highest exponent first. And then x plus negative 3x is minus 2x plus 2 all over x minus 1. This doesn't factor. I was just staring at it to see if it could, and it doesn't. Okay, let's subtract. I'm going to do f minus g. It could be the other way around. So f minus g of x. So x plus 2 over x minus 1 minus 3x. So right away, my domain. X, again, still not going to equal to 1. I'll go ahead, same exact process, multiply by x minus 1 over x minus 1. It's like multiplying it by 1. It's like just dilating something. It's not changing it at all. I'm sorry, it's not dilating something because you're doing it in the numerator and denominator. It's like multiplying by 1. It's like I get 2 sixths, the same thing as 1/3. That's all you're doing here. So you've got x plus 2 over x minus 1 minus 3x squared minus 3x. I didn't distribute a negative 3x, I just distributed the 3x all over x minus 1. So when I go to simplify this, I get a negative 3x squared. X minus negative 3x is 4x plus 2 all over x minus 1. I ran out of room for multiplication, division, and composition, didn't I? Oh no. I feel like you guys are going to hate this, but I'm going to do it above. I could have, if I don't know, my eraser doesn't work. Okay, let's do f times g. When I multiply them, x plus 2 over x minus 1 times 3x. Domain. Oh my goodness. Who would have thought x can't equal to 1? You don't need a common denominator for this. Just make sure that you distribute that 3x to both terms in the numerator. It's basically like it's over 1 and you're multiplying straight across. So 3x squared plus 6x all over x minus 1. Can't really do anything else with that. Yeah, can't do anything else with that. If I factored out, if I divided the numerator out by a 3x, it doesn't cancel anything. And then I'm going to go ahead and I'm going to do, you know what? I'm going to do g over f. So when I set this up, I've got x plus 2. No, I don't. My goodness, my friends. 3x over x plus 2 over x minus 1. Sorry, my pen is lagging. And I think the really important things for you to recognize right now when you're finding domain is that the entirety of this denominator cannot be 0. I have 2 things to check right now. Is x plus 2, where is this equal to 0? And where is this equal to 0? Right? I want the big denominator as well as the little denominator. So I've actually got 2 things here that I might not recognize if I tried to simplify first. So for a fraction to be equal to 0, the numerator has to be 0. If you didn't remember that, if you multiply both sides by x minus 1, I'm going to be able to get x plus 2 equals 0. So x equals negative 2 by not in the domain. And x cannot equal to 1. So I'm kicking 2 things out of the domain here. So now I've got the domain. So the domain is all real numbers, but negative 2 and positive 1. Everything else is great. Let's see. I think my bracelet is dragging a little bit. So I'm going to say 3x, instead of dividing by a fraction, let's go ahead and multiply by, x minus 1 over x plus 2. Multiply straight across, and you're going to get 3x squared minus 3x over x plus 2. Right? So that's why it's so important. Domain is x cannot equal to 1 or negative 2. Is to recognize that you need to do this right away, that you should not be waiting until you simplify to get this. Okay, I've got one more. I'm going to do composition. And hopefully my pen will last. So let's say I want to do f of g. So I'm going to substitute g into this. So I'm going to have 3x plus 2, so anywhere I see x, over 3x minus 1. Right here, my restriction, well, the denominator can't be equal to 0. X cannot equal to 1/3. Right? And then, I mean, if I go to simplify this now, there's not really much I can do. 3x plus 2. I'm very sorry, guys. This pen is my computer, the pen. I don't really know what the issue is right now. But we're almost there. Okay. So that's it. I can't really do anything else there. Okay, so I just wanted to emphasize the importance of doing it first. Finding the domain, substitute, domain, simplify. Substitute, domain, simplify. Make that your routine. Make it a habit to find the domain regardless of it asking. Right? Make that something that you are doing. So this was a lot, right? Like we did a lot of this. And then we transitioned and we finished up with some facts about inverses. Now that we've learned all about functions, we incorporated some stuff about inverses. And this was the final week of this unit, right? So this was last week, the week of September 29th. It's a reflection over the line y equals x. You're switching the variables, right? The domain and the range are switching. If a function, f of x, is 1-to-1, the inverse is a function, right? And this was one that we focused on again. If it's 1-to-1, meaning not just that it's a function, not that every input has one output, but every output only had one input that led to it. So for instance, a quadratic is not 1-to-1. This would be, does it pass both the vertical and the horizontal line test? That's what it needs to do to be a 1-to-1 function. This one was just a notation that kind of built off of that. If f of x has an inverse that is a function, it is notated like this. You're not going to be using this notation. You're not going to see this notation if something's inverse is not a function. Then you would just be using y inverse, right? That notation is inverse. It's not f to the negative first power. That's a notation that we're using to talk about inverse. And then this one, which incorporated the idea of composition, if you compose a function and its inverse, you get x. And what we talked about was the importance of doing it both ways, right? Like if you get one that doesn't work, while I encourage you to do the other to check your work, you don't necessarily have to. But when you are verifying, that means that they are inverses, and we ask that you do it both ways. And then finally, we talked about equations and amputations. And this was a little bit of a strange concept. We didn't do too much with it, so I don't want you to stress too much about it. But this was a focus on one of the issues with inverse, right? And so it was a focus on the idea that of being one-to-one. And how can you restrict a domain to force it to be one-to-one? So the big example that we used, and the one that comes up a lot for us right now at least, is a quadratic. Right? If you have a parabola, this is not one-to-one. Its inverse is not, in fact, a function, right? Many of you might know, or might have known, or might still think, that a square root function is the inverse of a quadratic, and in fact, it's not. It's part of the inverse, right? But if I graph a square root function, I get this. I need the entire thing for it to be the full inverse. So how could we restrict a domain to force the inverse to be a function, to force it to be one-to-one? And that's where we kind of restricted it where the issue started. And for a quadratic, that's at the vertex. So just paying attention to, like, are you looking at the top or are you looking at the bottom? Are you dealing with a positive square root or are you dealing with a negative square root? So that was what this last and final piece got at. And that was how we ended this unit. So, what else should you know? I want to talk about some of the resources that you do have. You have your notes. You have the video lessons, right? Like that is one of the perks of this whole virtual learning thing, is that right now you could go back and reference any of the instructional videos, right? Nobody before you could have done that. You can go back and you're like, you know what? I'm having trouble with this topic. I'm going to go back and rewatch that video. Do it. I encourage that. You have your notes to study from. You've got your classwork, right? You have all the presentations from class. You ideally have the work you did. Maybe you have the Pear Deck takeaways if you did a Pear Deck. Use those and put them together to help you create practice problems, or go back and pinpoint, where were my areas of struggle? Where did I have confidence? Because maybe I don't need to focus on those right away, right? We tend to like to practice the things we know well. I encourage you to practice the things you don't know as well, and to focus on those things first, and then end your studying with the things you had confidence in before you even began. You have your warm-ups, right? We've been encouraging you to write down all of your warm-ups. If we were in school, we would have an entire warm-up journal we would be encouraging you to take home to help you prep. Use those problems. We do some rigorous problems through the warm-ups. Use them. Let's say you were someone that you're like, oh no, I didn't write them down. I must have missed that memo, or I got lazy one day. It happens. You guys have access to every single presentation. Maybe you did it on a Pear Deck and you have the takeaways. You have your warm-ups, and if you don't, you have access to them. You can get them. You have any homework assignments. You guys now have a textbook. While we didn't assign really any textbook work through this unit, you have it. Go look at it, right? Start using it. We didn't use it because not everyone had it yet. That doesn't mean that it can't be a resource to you. And then you have all of those supplemental resources. You had lots of Delta math. You had some Quizlets, some quizzes, lots of practice worksheets. Use them to support your practice, right? You don't necessarily need to sit there and redo them, but pull different things and create a practice assessment for yourself. Create a practice assessment for a friend in trade. Create a practice assessment and share it with your teacher and be like, hey, do you think I missed anything here? Would you omit anything? Would you add anything? These are all great skills. As far as the test goes, you guys will have the entirety of the class period. So I said 60 minutes. It would be great if you all came like literally right on time, ready to start, because it's going to start right at the beginning of class. We would love to be able to give you the entirety of the class period. And it is like, we haven't used calculators or anything. Like, we've been checking things on Desmos and GeoGebra, and it's great for learning and creating that visual understanding, but it's not something we rely on. So there should not be a calculator used for this test. You guys got this. Review, study, think about the resources you have, and reach out to let us know how we can best support you. But this whole week is just designed for review and no new instructions, so that you have time to process and ask questions and learn how to kind of focus your studying. So hopefully this was somewhat helpful. You guys have access to this PowerPoint, and let us know how we can help. Thanks, everyone.